Okay, I'm Adrian Times. My company CubeCab launches CubeSats to low Earth orbit. In some ways, we're taking the opposite approach to Team Phoenicia. We just launched individual CubeSats. Now, we just launched to low Earth orbit. Low Earth orbit is quite a ways from the moon. So what do we care about lunar CubeSats? Turns out there's an interesting little synergy between our launch model and being able to do low-cost, rapid response missions, what people call responsive. I was asked to speak about that. So, next slide. Okay, I'd like to start by doing something a little unusual and include the rest of this conference as the bulk of my references. I mean, seriously, what can they do? Why would you want to do it? How do all the various components work? All the various challenges? The other presenters have gone on and on and on. I think I can take at this point that it's been established that this can work. And for those of you watching online, please do check out the other presentations. They're good stuff. They're listed above me on the conference page. Next slide. Okay, so start off with an example. What's the current state of the art of low cost? The Lunar Atmosphere and Dust Environment Explorer is a pretty good model. It is a good mission. Only about $250 million. State of the art for its time, for a few years ago. 223 days, they could have extended it a little bit. They deliberately went a little low. The main thing, though, is it took 5 years to pull off. That's what I want to show that we can get under. Next slide. Questions for the end, please. Okay, so what I'm proposing is your standard CubeSat swarm. Everybody here, I'm pretty sure, is familiar with this. The standard benefits, the standard cheap CubeSat, so if one fails, you can launch another, and so on and so forth. The main thing I want to justify is these three numbers. Next slide. Okay, so one of the main things is, how are you going to get up there? We're only launching it to LEO. Well, the three main semi-viable propulsion methods, chemical thrusters, ion thrusters, and solar sails. Solar sails, the Planetary Society is funding a light sail program. There's also a lunar sail program out there. There's people developing it. Ion thrusters, Axion Systems out of MIT, the CubeSat ambipolar thruster, again, that's being developed. And of course, there's chemical thrusters. Now, a little caveat, I'm not including R&D costs, I'm including the manufacturing costs that I got from, well, calling these guys and asking around. You're not going to find this info online. Well, except for in this presentation, but hey. Chemical thrusters, basically they're not going to do it. Not enough ISP. You get minimal payload. Ion thrusters will do it. They're a little expensive. So the cheapest model that I found is solar sails. Yeah, they're going to take a few months launch to get to lunar orbit, but you'll see in a bit why that's not going to matter too much. Next slide. So apologies, the video is not showing that too well, but your standard building orbit, you can find a lunar trajectory. I understand there was another panel on lunar trajectories earlier. So I just picked one off online, standard credit if you want to look them up. But your standard, you thrust out a little bit, you angle the solar sails to not affect your thruster on, or thrust on the inlet side, build up ellipsize until eventually you can do a lunar flyby, transition over. The guy showed it takes a little over 90 days to do it that way, using roughly the thrust you'd get off a typical solar sail. Okay, now we start getting to where CubeCab matters. So as most of you know, CubeSats, they have to go to the secondary payload. We call it the truck and the bus model for how you're currently getting stuff up. Either you red with a primary or you do a whole bunch of CubeSats. Typically, these take 1 to 2 years to pull off, as I'm sure Will Baird can attest to. But I found this is typical in the industry. Some do a little faster than 1 year, but 1 to 2 years is typical. You have to go where the rocket goes. There were almost 100 CubeSats launched last year. And according to SpaceWorks, we can expect 300 to 400 in 2016, just with the current model. We're doing a better model. We launched CubeSats as the primary payload. Very small rockets, 1U or 3U to LEO. Same price roughly as you'll find on the market. We do it faster, we do it better. Our engineering time per launch, we get down to less than the regulatory approvals. So I can safely say it'll take no more than 6 months because that's the maximum time the regulatory is allowed to take, assuming you don't run into many glitches. We help people get through the regulatory. And we have been told by the military that this is what they call responsive launch. They want us to see us succeed. We launch in, again, 6 months. Next slide. So let's take the numbers through. So you launch a CubeSat for 250K for a 3U through us. As I mentioned earlier, the 200K is for the entire CubeSat, including all of the propulsion systems, guidance, everything you need to get you up there, not including your payload. I did some checking around, and you can actually get a pretty good science mission, at least a camera, that would fit in a single CubeSat, a 1 kilogram payload, for about a 300K. So take that as reference. And a little more checking around, ground control and bare bones ground control, like you're hiring maybe a postdoc to run the science side, and wrenching time and telemetry. You can get that for 200K. So a total, less than $1 million per CubeSat. Even with a swarm of 50, less than 50 million. You launch in 6 months. You get there in 3 months. You get there in less than a year. That's a lot less than 5 years. Next slide. So yeah, Laddie took 5 years. We take less than 1 year. They had 223 days. They could have extended it. You got a solar sail. You're going as long as you want, and then at the end of your mission, you don't have to crash it. You can say, oh, sell a CubeSat that is in lunar orbit to someone else who wants to build infrastructure. Like, say, if they want to build a communication infrastructure, recover some of your costs. Or you can crash it if you want. And again, less than $1 million for a very bare bones mission, or 50 for equivalent payload. And yes, that's not 50 all in one unit. On the other hand, Laddie couldn't, say, spread its cameras across a kilometer-wide line. CubeSat Swarm can totally do that. Now, since I have some time, I wanted to give a shout-out to the regulatory guys. Yes, even if you're on the moon, your mission has to follow the law. And this is mainly a concern for the non-government guys who are going to be our main customers. FAA is going to be your primary point of contact. You have to get a license. Any launch provider has to get a license. You also have to get approval for the individual mission. They handle most of the coordination, so you know how you have to handle with NORAD and the international unions. They notify that. You do have to also get licenses from the FCC for whatever telemetry you're getting. Again, if you're outsourcing your telemetry, those guys will probably handle it for you, but someone has to contact them. If you're doing Earth observation, you have to do NOA. Now, technically, the law just says Earth, not Moon. I've actually read the law there, and it specifically calls out the Earth. Technically, it would include any Earthrise type photos, but their main concern is they want to have shutter control in case you're trying to photograph military bases or that kind of thing, which for this kind of mission, you're not. So just cover yourself, email them, and they'll probably email you back saying, okay, yeah, you're clear, you have that in writing, you're good. Now, currently, international traffic arms regulation covers if you have an international team. As of next month, a lot of this stuff is coming out of ITAR, but it's still export controlled. It's just being transferred out of ITAR to a less stringent regulatory scheme. The upshot is, talk to the Department of Commerce if you have international anything on your team. Make sure you're clear by them, get some guidance. The main shot here is just talk to these guys before you do your mission. Make sure you're all okay with the law, and you're probably going to be good. Just talk to them first. Now, questions. And I will answer what I'm sure is going to be the first one is we are currently in seed funding stage. We actually won the lightning pitch competition hold-up by the Space Frontier Foundation back in July. Mm-hmm. That got us some initial money. We're looking around for a lot more seed money. Mm-hmm. We are hoping, if everything goes to plan, to get to $100 million valuation 5 years after funding.
Mm-hmm. Good, thank you. And then so how much do you envision, like the previous speaker, that your actual product will be the services associated with getting people to be able to launch?
So that is where we are taking the opposite philosophy from Will, who is a good friend who I've known for years, by the way. So he's taking the expensive integrated part. We're going to no frills part, very much the DIY, which is why I included that slide about shout out to the government, because with our thing, the customer's probably going to be talking to the government. Oh, and by the way, so that slide was if you are a U.S.-based team flying U.S.-flagged spaceships, it is basically equivalent to international maritime.
Yeah. And then I guess also just to be clear, your basic technology is an air-launched small rocket.
Small rocket primarily, but yeah, air launch as well. It's the service model of get you up, get you going, without having to coordinate with any other ride at all.
Thanks.
Pamela Clark, Lecture Engineering. We've actually been looking very carefully at CubeSats for deep space applications for the last couple of years. So let me give you some data here. So getting from LEO to anywhere is really hard for CubeSat. Probably with the present technology of developing propulsion systems, just for the CubeSat, and I'm not talking about carriers, but for CubeSat, you probably want to get the GEO or GTO. And anything less than a 6U CubeSat, because of the control systems you need when you get outside of LEO, you can't use the Earth's magnetic field. You need active control systems, and you do need a real propulsion system, even if you get released at your target, to get to where you really want to go. And you need at least a couple U for the payload. So you're talking about probably a minimum of a 6U for a reasonable, and that includes, for example, if you're going to use solar sails for stowed solar sails. And it is probably, unless you're using a carrier with more conventional propulsion, at least 6 to 9 months to get to your final destination at the moon. Probably more to get the orbit you really want to be in. So that it's a different regime to some extent for deep space because there are a lot of advantages you have for LEO that you just really don't have once you get outside LEO. And there are certain minimums that minimum space you need for things.
Okay, that's why I mentioned the 4 companies I mentioned. They're all working on 3U, not 6U, but 3U form factor propulsion systems. And they can get you with a 1U worth of payload to the moon. But all 4 of them can do that.
But 1U is not enough payload space for most applications.
Actually,
if you're talking about a real scientific instrument that allows you to do sensitive measurements and
yes,
imaging?
I am. That's 300K.
No, you're not.
That's
no, you're not.
Pamela, we'll pick this up later. There's a wide spectrum of, again, we're talking small businesses here, so ultimately it's whatever you can sell. If your customer's happy with 1U, then 1U is good enough. No,
actually, I was finding quite a few examples which can be done in 1U for 300K and are real scientific instruments, including telemetry. Next question.
Okay. What we're going to do is we're going to save this discussion. It's an important one. We're going to let some other people ask some questions, and we will include this discussion in the design challenge. Cool?
Cool.
Okay. Chris, and then...
Just a quick question. When do you expect to have your launch?
What? Say again?
Sorry, I may have missed this already, but have you already had your launch, or when do you have this?
We're still in development at this point. We expect the first launches will be about a couple years after funding, roughly.
Okay.
Okay. Okay, a couple of questions. You specified a 3-month transfer using a solar sail. What was the initial orbit from which you did that transfer?
Leo?
I strongly don't believe that answer.
Look up the trajectory that I cited. That's why I included a reference.
That seems exceptionally short for transfer. Also, a solar sail operating in LEO is doing good just to avoid falling out of the sky due to aerodynamic drag.
Look up the.
That's fine. That's fine. Do you have a full URL or something to look it up? And besides that, even if one can look it up, you can look up a wrong answer as easily as you can look up a right answer. When you talk about air launch, what sort of aircraft are you planning on using for the air launch? How large is the rocket?
We're currently thinking a Starfighter. The Starfighter group out of Florida.
Yeah.
In fact, some of our team are going down later this month to talk to them. And they've been in initial email negotiations.
Get with me. I live there. I'm with them this week.
Talk to me after this, yes, please.
Excellent. Thank you.
All right.
Okay, question. How do you mentioned the compliance of the law. How do you determine if you're in compliance with the law, Charles?
How do you determine the compliance with the law itself?
Yes, you go to agencies, I may be in violation of ITAR, and they may just come bang on me one day and say you're in violation of the law.
Okay, again,
I didn't even know
talk to those agencies to determine the violation. They are the ones who make the determination. We're just another startup.
Okay, so which agencies, because you may speak to agency A and there was an agency B that you didn't speak to, they got prosecutors.
Federal Aviation Administration is going to be your primary point of contact.
Thank you.
Federal Communications Commission for any telemetry. National Oceanic and Atmospheric Administration, if you're doing anything that could be interpreted as Earth observing, which again technically includes Earth-on type photos, but again, they're more concerned about near Earth, so you just have to talk to them and say you're clear. And then for international stuff, previously it was the Department of State. With the transfer, it's largely becoming Department of Commerce now. And that's only if you're doing any possible transfer of technical information or technical objects to non-U.S. persons.
So yeah, we'll move on
Let's come back to FAA has a number of departments. Where do you start? Which one?
Yeah, you hire a good lawyer because it's not as easy
Actually, you hire a good lobbyist.
Yeah.
Lawyers, if you're doing any kind of Earth return, if I may digress on that, if by some miracle you happen to do any kind of return of objects from beyond the Earth's atmosphere, a lot of people will say that that's not settled territory. Do have a lawyer for that, but there are a few cases out there where people claim to have real estate licenses for the moon. The courts have tossed out every single one of them. Again, this is just U.S., but there's starting to be some precedent for if you bring it back to Earth, it's as if you picked up a meteor. It is yours. Now, currently all moon rocks belong to NASA because NASA's the guys who brought them all back. But I am not a lawyer. This is not legal advice. The only advice there is have a lawyer.